Good morning everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about the various examples and case studies with related to the open issues and the challenges. The first challenge in data communication is an intercommunication, then interoperability, then exitability, where it uses the necessity for the standardization. Then IP version 6 addressing must be used in order to lead the way. Then the components designed with predetermined parameters. Then impregnability, it is nothing but confidentiality of data has to be maintained here. Then the management of identity or of that particular privacy has to be done. Then we have to control those access. Then finally encryption. Then extensibility, here we have to enable a higher number of smart objects and executable management process which is being developed. The next one is extensibility. Here we have to enable the higher number of smart objects, then identification, then movability, then big data, and the management of energy. In movability, we have to detect the movement which it is to be required. Then energy and the processing restrictions should be an existence. Then in big data, the qualities of the data management service have to be used in order to have the direct correlation with the performance. Then the data integrity attribute should be maintained. Then green technologies are required for energy efficient systems. Then we have to be used that energy that has to be used completely. Then the challenges in data communications, that is networking in internet of robotic things, is nothing but we have to first consider the global IoT market size, then how to larger those data manufacturing, then IoT technology investment, academic interest in IoRT, and the possible return of investment of IoRT business. The future of IoT technology seems extremely bright and promising. However, because of the immense scope of the IoRT infrastructure and the large number of devices installed, security issues will be much more prevalent. Then the security procurement is required in order to disarm malevolent actors that pose a danger to the IoT, and it has yet to be satisfied effectively as seen in the preceding sections protocol. The security concerns posed by IoT will serve as a crucial research topic. The open networking problems in the IoT area are summarized in the table. Aside from security provisioning, compatibility between network protocol is another major difficulty in the IoT development. Then, leading the firms throughout the world are designing smart devices with complete interoperability in the mind. These features are critical because they will allow for seamless interactions with the present internet. Then the expense of an IoT protocol with numerous sophisticated capabilities rises as the convenience of the use decreases. Building an attractive protocol is not an easy undertaking, and it is usually a trade-off between the system cost and the performance. The Internet Protocol version 6 introduces beneficial and adaptable networking technologies, which brings IoT futures one step closer to the desired interoperability. The Internet of Things will connect a variety of things to create a revolutionary services. Then, moreover, IoT data is characterized by heterogeneity, which implies that information is created in large quantities, which arrives in real time and has a changing structure and may have an unknown source. Then, because of this total performance in a straight line proportional to the characteristics of the data, managing the service here, then the problem of managing the massive data will be crucial. Then whenever the data integrity component is examined, the problem becomes much more problematic, not only because it impacts service quality but also because it raises the privacy and the security concerns, especially with the outsourced data. Then another important aspect of IoT paradigm is mobility management. Because of the hot processing and power limits, conventional mobility supporting protocol for vehicular ad hoc networks, that is VANETs, sensor networks, mobile ad hoc networks, and are unable to effectively cope with common IoT devices. To keep track of the device's location and response to topological changes, movement tracking is required. Then furthermore, the energy needs of IoT are yet unmet. A few routing protocols, as previously mentioned, offers low power data exchange. However, they are still in the early stages of development. As a result, green technologies must be used to make IoT devices as power efficient as feasible. We have seen the various challenges in the networking, and we have also explained the characteristics of the intercommunication in IoT.